21. The wavelength of a wave doubles as it travels from medium A to medium B. Compared to the wave in medium A, the wave in medium B has half the speed, twice the speed, half the frequency, twice the frequency. So let's draw a little sketch of what's going on here. We got a wave, and it's traveling from... Actually, you know what I'll do? Instead of drawing an arrow, I'll draw the wave fronts. So here's this wave, and these are just the wave fronts. I'm not drawing them perfectly, but I want you to imagine that they're perfectly parallel to each other, and they're traveling that way. And right now they're stuck in medium A, right? And then eventually they're going to pass this point and they're going to go over to medium B, and when they do, the wavelength will double. So if these are the wave fronts, if these are the crests of each of the waves as they travel toward medium B, when they get into medium B, they're going to be twice as far apart as they are now. So they're going to look like this, right? So here, the distance between these two is lambda units apart. Lambda is the unit for the wavelength. And here, they're 2 lambda. It's bigger. So, what does that mean? That it's traveling from medium A to medium B, and now all of a sudden the wavelength went from being lambda to being 2 lambda. Well, it must mean that this medium A is relatively dense, and then at B it's less dense, and that's what has allowed the wavelengths to be further apart. And now the formula for actually solving this is given on your formula sheet, is V equals F times lambda, where V is the speed of the wave, F is the frequency of the wave, and lambda is the wavelength, as we talked about. So if the wavelength is getting bigger, it's being multiplied by 2, it's going to become 2 lambda, then what impact is that going to have, and on which variable is it going to have? Well, it turns out that as a wave goes from one medium to another, its frequency actually stays the same, so there's no impact to the frequency. So that means that these increases in the wavelength must be seen in increases to the velocity for this to be still algebraically true. So if this becomes 2 lambda, then this is going to become 2v. So twice the speed is the best choice. So really the key to this is realizing that the frequency stays constant when a wave goes from one medium to another. If you didn't know that, you wouldn't be able to figure out whether it was 2 or 3, right? Because suppose you thought the velocity stayed constant, then it would be the frequency that would have to go in half, and 3 would look like a pretty good choice. 4 and 1 don't make any sense. So you could certainly get it down to 2, but it's realizing that the frequency is constant that locks you into 2, which is the best choice.